Here's a real-world type example using transformations of functions. So this is a particular roller coaster. The Wild Ride has a section that is shaped like the function g of x equals negative x squared over 30 plus 10x over 3 minus 100 over 3, where g of x is the vertical distance in yards the roller coaster track is from the ground, and x is the horizontal distance in yards from the start of the ride. Describe the transformations of the parent function f of x equals x squared used to graph g of x. Wow, that's kind of a messy looking function, and we haven't really seen things like that with parabolas. One of the first things I would do on this one is I'm going to rewrite g of x, and instead of writing it as a fraction in this form, I'm going to write it as negative 1 over 30 x squared plus 10 thirds x minus 100 thirds. So now it's in the form of ax squared plus bx plus c. So this is in standard form. I'll say y equals. Now, in order for us to compare it to the parent graph, when we compare f of x equals x squared to g of x, we'd like the function g of x to be in the form a times x minus h quantity squared plus k, which was graphing a vertex form. So now the question becomes, how do I change this form into this form? So we're going to do a simpler problem just to kind of review that with you. So let's take a look at something that would be similar to what we did in Algebra 2 and see if we can change this into vertex form. So my value for A is 2, B is 4, and C is 3 for the standard form. Now, if you remember to find the vertex, to find the x-coordinate of the vertex, which in our equation would be h, we took the opposite of b over 2a. So if I do that, I'm going to get negative 4 over 2 times 2. So we get negative 1. That's the x-coordinate of my vertex. How do I find the y-coordinate? Substitute that value back into my function. So if I evaluate f of negative 1, I get 2 times negative 1 squared plus 4 times negative 1 plus 3. Remember, when you square a negative 1, it's going to be positive, so we get 2 minus 4 plus 3, so we get 1. So our vertex is 1, negative 1. If I wanted to write this in graphing form, I would have f of x equals the value of a, remember, is this same value here. It's the same a. So we have 2. This is h. This is k. So we're going to have x minus h, so x minus 1, quantity squared. And it's plus k, so plus a negative 1, or we could just write minus 1. So here's my equation in graphing form. So now let's go back to what we were working on, and let's try putting this in graphing form. So remember, we started by finding the vertex, so the value of h is the opposite of b over 2a. So I look up here, and b is 10 thirds, so I'm going to have a negative 10 thirds over 2 times a, so 2 times negative 1/30 is negative 2/30. And I have to simplify that. Now, don't be quick to grab your calculator, because remember that this fraction bar here means divide. So when we divide by a fraction, remember it's the same as multiplying by the reciprocal. So I'm going to flip this over and have negative 30 halves. Now I can do a little bit of canceling, because 3 goes into 3 once, 3 goes into 30 10 times, 2 goes into 2 once, 2 goes into 10 5 times. So I end up with a negative times negative is positive. So I end up with a positive 50. That's my x-coordinate for the vertex. How do I find the y-coordinate? Plug it in. So we need to do h of 50. So I need to substitute that in, and we get negative 1/30 times 50 squared plus, okay, I should be consistent here, and I should have had this remember if this had been a negative, that would have been an issue the way I wrote it, plus 10 over 3 times 50 minus 100 thirds. And if you substitute that in, I'm not going to take the time to show that, but you will actually get 50. So now if we think about what that tells us, remember this is our vertex, so now we know that we could rewrite, did I change it to h of x instead? Oh, I don't know why I called it that. This should be a g right here, sorry. So if we evaluate g of, if we write it out now, g of x equals, now remember what I said, the a value doesn't change from what it was before. So what was it? It was negative 1 over 30. So we get negative 1 over 30, and we have x minus the x-coordinate, h, quantity squared, plus k. And remember, this was k. So here is our equation in graphing form. And now the direction said, or the question said, describe the transformation. So now I can. I see that it's going to be flipped upside down. It's going to open down. And it's also going to be compressed vertically. So it's going to be wider. Then we also have it shifted 50 to the right and 50 and 50 up. So we end up with, actually, we know the vertex is 50-50. So this gives us some information. And if you graph this, you could take on your calculator, if you graph both of these and verify that they do match up. So here's a part B of that same problem. Now you'll notice this is the same function, so they didn't change it, so we don't have to redo that. And what we're being asked to find here, the ride designers decide to increase the highest point of the ride to 70 yards. Rewrite g of x to reflect this change. Well, remember, we already know that g of x equals negative 1 over 30, x minus 50, quantity squared, plus 50. So since we know it's a parabola that opens down, even without graphing it on my calculator, I know that this point here has to be the maximum height, and so we know the maximum height based on g of x would have to be 50, because that's the y value of the vertex. So now we want to increase it, not by 70 yards, but to 70 yards. So that means we just want this value to be a 70 instead. So you just change this to g of x equals negative 1 over 30, x minus 50, quantity squared, plus 70, because now my maximum point would be located at 70. So you could verify this on your calculator. That's what they had actually said to do. I'm not going to take the time to do that, but you would see that this indeed goes up 20 additional yards.